3. Okay, here's 6.4. Thank you. Modeling data using exponential functions. So we're going to use a lot of skills you already have, hopefully, today. It'll be a good day. A biologist was monitoring the growth in the number of fruit flies, which are disgusting, in a controlled environment. The fruit fly population was recorded over a fixed, this is supposed to say a 5-day. This D is supposed to be over there. 5-day period. As shown, how can you estimate when the fruit fly population will exceed 160? Yeah, you could do that. Plot them in our stat. Okay. Okay, so you're saying we can go to our stat. And then last unit stuff, edit. And put in L1 and L2. Okay, so let's see. Now, what kind of growth? We're going to try and estimate which type of growth this is. So edit, remember, go here. Don't click delete. Clear. Hopefully I'll be haunting you in your diploma exam. You'll think things like don't click delete and turn my diagnostics on. And am I in radian mode for trig? Oh, it's actually always on. Degree. Remember second catalog. Okay? But now this type of like bacteria or even the reproduction of any type of species is usually modeled by an exponential function. Why do you think it is that way? The more we have to mate, the more we have, the more mating that can occur. So so as more grows, it's an exponential growth type of function. Now, in an exponential growth, we're always multiplying by the same thing, right? Approximately. How can I get what we're multiplying by from our data? No? We don't have to guess and test. If I want to go 70 times something equals 76, how could we figure that out? Divide. Divide which one? 76 divided by 70. Term 2 divided by term 1. So that rate, some of you dealt with this if you took 20-1. So 76 divided by 70, which gives you approximately, let's make sure calculators, I should give my calculator a name. 1.09 approximately, right, is the rate. Okay, so anyways, did you guys, so when we have it in our list, you have to make sure your plots are on. So the easiest way to check your plots on are right there, right? In our main window, we go stat, calc. What did you guys go to? Linear. It's not linear. No, it's just because you're seeing a very small portion. It should be at EXP, which is 0. So if you push the up button or just push 0, it's exponential. No, because whenever we have a breeding situation, it's going to be an exponential. Okay? So, I'm telling you, that's when we're breeding. That's the type of situation we have. It's like bunnies, right? Never mind. Okay, so 0, and then what do we do next? Vars, Y vars, enter, enter, enter. Oh, what did I do wrong? It is embarrassing, isn't it? Okay, second enter is my best friend. Okay, so zoom at what, 9 will give you your zoom fit. And there's our exponential equation. You know what? The problem is when you're given data that's like down here really close together, it has a very, if you're just zoomed into this part, you're zoomed in here, it looks linear, but as time goes on, it actually is exponential. No, 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 no. Okay, so we did, so that after that we went second, we went stat, then we went to calc, over to calc, and then we went 0 for exponential regression.
And then you go y to 160, and you find the intercept.
Okay, so we want when there's how many? 160, right. So that's a y value. Here's our x's, here's our y's. Time is always our x. So in our graphing calculator, we go y equals 160. Okay, so we'll go through these steps again. Zoom out. Okay, so okay, so we went to stat and edit, right? That's our first step. Okay, so then after we have that done, we're going to go stat again. Then we go over to calc. Now the easiest way, you can either push the up arrow, if you want to get to 0, or just push the number 0. So I like just push 0 because I'm getting the habit of just pushing 0, right? No, just when you've typed it in a million times. I've just done this more times than you. Bars. Okay, so I'm going to write this down. Bars. Then we use the right arrow over to y bars. And now we went to number 1, which is function. So y bars, number 1, which is function. And then number 1, which is y1. Enter, enter. Yeah, enter. So really what you do after you go here, you can push enter 3 times.
Then you go y equals, you go to y to 3160.
Okay, are we all caught up to that part there? Yeah? Okay, the reason, so they say, how can you estimate when, so when is a time, so how many days, the fruit fly population will exceed 160. That is a y value. So for any y value that's given, we have to go to y2 and put that in. Okay, so what's the problem with this right now? You can't see it, so we have to zoom out. How do we do that? Zoom, 3, enter. You guys are getting really good at this, which is good. Remember when you first learned this stuff? Okay, I still can't see. Oh, there I can. And what are we looking for? Intersect. So second, trace, 5, 1, 2, 3. And there we go. So our x value would be approximately how many days? 9 days. Oh yeah, you could do that too. Good idea, Brady. So Brady said what we could have also done is go to our table. Try closing the door behind you. Okay, so here you could go down our scale there at, we want 160, and so 9 days. That would work too for estimating. Well, the question is what if you want something that's other than a whole day, right? It's not accurate if I said to the nearest tenth of a day. Yes. Yeah. Okay, so let's go at least through a couple. This is the key ideas is all review, so let's skip that. The things to remember are all review. So let's skip that. Determine which of the following data sets involve exponential growth or decay. Explain how you know.
What's decay?
Decay is our b value is between 0 and 1, right? It's decreasing exponentially instead of growing exponentially. Okay, the first guy, is this going to be exponential? So here's one way you can check. This guy divided by this guy should equal this guy divided by that guy, right? Because if we're multiplying in an exponential, if we have to multiply by the same thing each time, term 3 divided by term 2 should equal to term 4 divided by term 3. That's one way to check. Or, I mean, logically, are we multiplying by something each time here? We're adding. We're adding what? 5.1. So what kind of function is addition? Linear. This is linear. Because we are adding. Okay. This guy. Could this be exponential? Are we multiplying? So an easy way to check this, I'll start with 2.5 divided by 1. What's 2. Thanks. 1 times what would give you 2.5? 2.5. Okay, so 2.5 times 2.5, does that give us 6.25? Yeah. So would this be exponential? Yeah, so exponential because we are multiplying by 2.5. Easy peasy. Okay.
There's a lot of stuff put into this. Let's have a race.
Okay, let's go. Let's enter this. You are all beat me. I promise you that.
Don't start yet. Yeah, don't start yet. Let's clear some stuff.
I guess we're going to make a competition. So stat, edit. If I...
Which one would be X?
Oh, so let's talk about X. So if they don't tell you, so here Samuel and his grandfather record the length and mass of each rainbow trout. So in this case, it kind of doesn't matter. So in that, we just use top first is X, second is Y. Right? Because length can affect mass and mass can affect length. More likely, length affects our mass. Okay. So remember, clear, not delete. Okay. 270, 392. Are you guys done already? Oh. Okay, should you just... I'll do it with you. It's always better. I'm trying. Somebody read the numbers. 351. What's after 351? 309. What's next? 414. 388. 440. 266. 338. Okay, next one. 210. 622. 80. 474. When you're in your diploma, can you all do me a favor? Be very careful and slow, because if you mess up one digit, it's going to affect your answer. And on a numerical response, if you round incorrectly, then you're not going to get the mark. Yeah, so rounding is so important. It breaks my heart when I see that on your test. You rounded wrong. Okay, so what's our next step? So quit, sure, second mode. Stat. Calc. 0. Just push 0, then you don't have to go scroll down. Bars. Y bars over. Enter, enter, enter. Okay, so the easiest way to get our graph, zoom 9. Does yours look something like that? You're crazy looking. What's wrong? Okay, so when I went, so here, after I did push the exponential regression, vars, so variables. We go over to y variables. And then number 1 for function, number 1 for y1. So we're saying put it into y1. Put the regression into y1. Okay? The only reason why your equation is different is you typed a number in differently. Okay? Okay, so determine the equation. So usually they'll tell you. So on an exam, I might say, okay. So what I might tell you is, so if this is our equation, a diploma question, often what they'll do is the sum of A and B is. So they'll do things like that. Or they'll say 2 times A plus 3 times B is equal to. So you'll have to actually work with these numbers. That's often what they'll do with it. So you'd add these two together. So in a numerical response, they'll say the sum of A and B. So you type in 96 point, you type in all this plus all of this. And that will be your answer. Okay? Push Zoom 9. Zoom. I have a handout for all this stuff if you'd like, an extra one. Okay. So it says Samuel caught a fish that measured 400 millimeters. Is that our x value or our y length? X. Okay, estimate the mass. So how do we do that now if we have the x value? Second, trace 1 for value. Jesse, you need to go to the office. You need to go. Did you go already? Oh, okay. Second trace 1 and then put as long, if it gives you an error, you need to zoom out. So what would be the mass? 689.5. And it says to the nearest gram actually, so we would have just said 690 grams. The nearest gram. Okay. If you can't see the graph, yeah, you have to make sure your plot's on up here. So in my graph, they gave us the x value. Second trace 1. We're going to enter in 400. And then you should get 689.
Yeah, that's what I got like 5 minutes ago.
There's more than just you in the room. I'm sorry. Oh, good.
Yeah.
Okay. Is it not working out? Let me see. Okay. Okay, last question. Can you try this one on your own? Samuel's grandfather would like to catch a fish with a mass of 100,000 grams. How long would it be? You're finding x, they're giving you y. This time they gave you a y value. It's 1,000. You might have to zoom out. Did you? Okay, once. If you don't see that horizontal line, you push zoom 3. So zoom 3 to zoom out. You have to push enter. If you don't push enter after zoom 3, it won't actually do anything. Second trace 5, enter, enter, enter. We get one answer, which is 446 millimeters, the nearest milliliter. The nearest millimeter. Okay, so I know that there's one more question, but I think we're good, right? Yeah? Yeah? So we're going to end it here. One more, your homework is all of 6.4. If you are struggling with this calculator stuff, so if you were like maybe missed some of the last unit, I have a handout on regressions that's been made recently by my buddy, so I can edit it. So Mr. Tran is a friend of mine. How come it's not letting me move?
All the questions?
Yeah, all the questions. Hello. second. So if you would like this booklet, it has, come on, there I go. So it has all this in here. Diagnostic on. Not all of them, but my buddy Dave taught it last semester. Yeah. And I helped him with previous year stuff, and he made the 30-2 last semester because we have to develop it from scratch, right? So I had nothing except for what he gave me. Yeah. So, yeah, if you would like that, just let me know. I'll print some out, and you can have it. Okay, I'll print off some. Yeah. I'm not sure. I'll ask them. You know them? Yeah, we totally do. We will.